in the text box.
My name is Brian Ingalls. I'm an associate professor of mathematics at the University of Waterloo. I was studying some fairly abstract mathematics and I was looking for an application, and I went to a talk by actually someone doing synthetic biology, which sort of opened my eyes to the fact that you can see biology as technology. I found that very exciting, and so I spent some time studying molecular biology, and really that's my attitude towards biology, is that it's a technology, and so we can describe it using mathematical tools the same way we do in any other engineering discipline. Math is an important tool set for describing the world, essentially. So we can use it to describe the natural world and the sciences. We can use it to describe the applied sciences, engineering, medicine, that sort of thing, and social constructs like economics. It provides a very powerful tool set for describing and hence being able to manipulate things in a lot of different contexts. Synthetic biology is essentially the engineering of cells and their constituents. So it's primarily genetic manipulation of these cells, and you can think of genetic engineering as sort of the first approaches towards synthetic biology, where you take a protein from one organism and transfer it into another, and that would typically give that new organism one new trait. So for instance, drought tolerance in a crop or something like that. So I'm in math, and so what I do is essentially support these activities by providing mechanistic predictive models of how the cells are going to respond to these changes. So we use differential equation models to describe the intracellular networks, and when those models are in place, we can then make predictions about how those networks will act under different conditions, how they'll respond to different types of perturbations and such. Keep in mind that math is a tool set, so it's often not presented as a tool set, it's presented as this self-enclosed entity, and I think especially the high school level, sometimes the presentation doesn't get outside of that box. But really, when people are using math outside of, say, high school, what they're doing is they're applying it in different directions. And so really it's this question of what can I do with these tools that should be in mind whenever you're studying math. Because 99% of the people who use math are using it as a tool set to describe the world. And it's a very powerful tool set. It allows you to understand and analyze and manipulate an awful lot of the things that we interact with.